All right, folks, it is 2:01. We're going to go ahead and get started. First of all, I want to say welcome everybody to today's presentation of the Corridor Productivity Pack from CTC Software. We're here to talk about custom subassemblies for our Civil 3D corridors. My name is Kyle Groves. I'm an EIT and a technical specialist with ATG USA. And as a little bit more background about myself, I've been with ATG in one form or another for about the last year and a half. And I am very excited today to share with you all some of the enhancements and improvements you can make to your drafting life by showing up and taking a look at the CPP. So with that, we're not going to spend a whole lot of time in the PowerPoint today, but I do want to go over what is the CPP in the first place. So these are a set of powerful custom-built subassemblies. These are better and different than the out-of-the-box ones for a variety of ways, but it's primarily because we've got ourselves the opportunity to define realistic geometries and parameters that actually make sense when we're trying to go through and modify them. So with that, we also have the ability to customize most of the codes in most of the subassemblies. And I'll get into why that matters in a few minutes here inside the presentation. But suffice it to say that once you've got a well-oiled code set, your corridor modeling life and your corridor plan production life just becomes so much easier because almost all of it's just done for you automatically. There's also a really large ability to set up different targets for these subassemblies, targeting that you don't get with the out-of-the-box, or that might be clumsy or cumbersome for you to go through and build your own subassemblies inside SAC. Speaking of SAC, we created this in partnership, at least at Legacy CTC, created this with the user in mind, saying, hey, we got you. You don't have to have somebody become an expert in subassembly composer. If, however, you do find that these subassemblies still aren't quite what you want, or if you'd like to go ahead and pre-populate some of those custom codes for the terminology that your firm uses, you still can bring these into SAC and modify them to your liking. Lastly, it wouldn't be a well-built subassembly if it didn't have a great help file. So all of these do come with help files and should give you additional clarification on what exactly our design intent was and how we wanted you to be able to use that in your design. So now that we know a little bit more about what the CPP is, let's talk about how we can use it. First, we want to understand that the modifications of your subassemblies need to be intuitive. So when you go and look into the properties palette, you want to be able to look at a row and say, this is what I'm trying to edit, and be able to edit it. Some of the out-of-the-box ones are just downright confusing on that point. And the biggest thing, in my opinion, about why the CPP is great is because it makes your code set do the work for you, for your plan production and for your design and your modeling. So there's a bunch of different ways that this can shake out. We're not going to go into a deep dive on code sets today, but we will dig around in them a little bit. Effectively, we're going to make our code sets work for us because we can use our point codes from our subassemblies to create and display feature lines for us. We can use these in plan production, or we can use these for other design tasks inside the software. It allows us to have greater flexibility for our QTO and for our material lists that we use in section view. It automatically labels and hashes objects for us in our sections once we have those built in our code set and we use the correct codes in our subassemblies. Another thing here is if your firm does survey, then you now have the ability to let your civil team use the same codes that your survey team is using. So we'll check that out in a minute, but basically with the out-of-the-box subassemblies, there's not a whole lot of codes that you can use to customize, and some of that customization is really limited. So if you find yourself using mark points all over the place to help bring on that flexibility, then the CPP is something that you might want to consider. Lastly, there are a couple of different subassemblies in here that help automate the link to mark point workflow. of skipping forward to important design information and just allowing your corridor to fill in the middle space. I'll demonstrate one of those, but I'll point out that there are a few where that is an option. So with that, we're going to go ahead and hop right into the software. All right, so I can see here in this file, I've got just a nice long corridor running through. I've already got my profile, my design, and my existing created, and I've even got my corridor set up some already. So I'm just gonna adjust my layout here and get back to the swing of things and kind of chop up my viewports so we can take a good look. Right now we'll see that I've just got one assembly here in my drawing, and I'll come look down over at this point. So when you get the CPP, what you're gonna find is a download package full of PKT files. PKT file is very easy to bring into Civil 3D. You simply go to your tool palette, right click, and go to import your subassemblies. You'll run out and find those, and you'll notice that there are 3 different categories that we offer. There is the imperial set, there is the metric set, and then since CTC was originally doing work in Minnesota, or primarily with Midwestern firms that also did work in Minnesota, there are a few subassemblies that have specifically referenced the Minnesota Department of Transportation curb. And then you'll simply grab all those and bring them into your tool palette. Since they're already in, I'm not going to go ahead and do that. But you'll go ahead, you'll put in your assembly, and you'll start creating this as you normally would. This subassembly that I have shown, the assembly that I have shown on the screen, is currently using the Workhorses, the bread and butter of typical roadway design in a corridor. We've got the multi-layer lane, which is a lane that is a lot like super elevation AOR from the out-of-the-box setup. And with this, we've got multiple different lifts that we can do. We can modify the thickness of up to 3 of those lifts. If we don't need all 3 lifts of pavement, we could simply come over here to the number tab. And once we switch from the different numbers that we're going to be using, our subassembly updates for us automatically, and we're only going to be able to see as many as we want to see. So I'll leave that at 2. Most of these values, all these values are editable from a thickness point of view. But notice too that now when I come down and look at the bottom half of this screen, all of these areas with codes are not only editable, but I can edit them in a completely customized way. So for example, if I had a shape code called ABC123 living in my code set, and I'm using it in my subassembly, the rest of my drawing is going to find that and pick up on that through the rest of it. So I'm not even limited to a drop-down like I was in the out-of-the-box subassemblies. I could just go through and I can modify that for whatever. What else do we have coming on here in this assembly? We've got a curb. Now, this curb that we're using here, this is just the general curb. I'll take a look and show you through the MnDOT curb in a few minutes. But the general curb has a couple of really great things going on with it. First of all, our sub base is sloped. That means that when we're creating our surfaces for our corridors, we're going to have a lot less to worry about for that overhang correction parameter. And I don't have my surface created yet, so we'll go ahead and we'll see that right in here. But this is just a more realistic version of how this is going to be built in the field, and it also is a more realistic way to work with how Civil 3D defines these parameters and works with them together. Another thing that you might notice is when I'm modifying my curb, I've got different parameters that I can modify as far as the dimensions are concerned, like the gutter width, the thickness, the depth of the top, the height, and so on and so forth. And when I start messing with this, as usual inside Civil 3D, it's going to update that information for me automatically. But I can see that all of these different values that I am editing are easy for me to identify right here in the properties palette. And so if I were to just pop in the generic or the general curb from the OTB, Urban Curb Gutter General, just pop it in right down here. It's missing the base and the subbase differentiations. We've added an extra shape in there. But also, when I come here to start modifying the rest of my dimensions, I have no idea what dimension C is. I have no idea what dimension E is. I'd have to go in and I'd have to find the subassembly help and go dig up that chart and that diagram to just even understand what it is I'm modifying. Or I'd have to come in here and say, oh, well, it started at 6 inches. What if I move it to 12? Okay, now I know that I don't even know what dimension D does. Oh, it's this back height right here. You know, I got to go through and do a bunch of trial and error to figure out how this is all going to work. So we've really been working with CTC to help make sure that the client has an opportunity to fully customize and easily, intuitively customize and create their corridor. And you'll notice these subassemblies are very similar in intent and in functionality to the out-of-the-box ones. They have more data to them, allowing you to create a more dynamic and more data-rich design. Another subassembly that is pretty fun, and we will check this out inside the drawing, is we've got this sidewalk with boulevard, which is going to put us in an inner boulevard, a sidewalk, and an outer boulevard. But we've actually got one that says from right-of-way. Now, by show of participation in the chat window, can I get anyone here to speak up if they've used MarkPoint and link to MarkPoint workflows before? And what I mean by that is if you go and if you check out the out-of-the-box generic tab, you'll notice that there's two subassemblies called link to MarkPoint, numbers 1 and 2, and then a MarkPoint, which basically says, hey, I'm interested in certain design information. I know where my center line of my road is going to be. I've got a certain slope going down, my curb. But if I wanted to, say, be working in an urban environment where on the outside of my roadway, I've got some fixed stuff that isn't going to move. Maybe it's the actual right-of-way of my corridor. Maybe it's the building line going down the city block. I'm not going to move a building back so that I can have an extra 6 inches of roadway here. That's not how that's going to work. But I have to have my sidewalk designed at a certain slope. I have to have this distance between that known feature on my outside and my sidewalk. That has to stay. But whatever happens to this, stuff in the middle, I need it to be independent. I need it to just connect from the edges of my two known points and just fill it in. So that is what this sidewalk with boulevard from right-of-way is doing, is it's automating those link to MarkPoint workflows, so you don't even have to build those mark points or mess around with that. We have a couple of different subassemblies available in the CPP that handle that right now. There's a sidewalk with boulevard from right-of-way, and then the multi-layer lane to MarkPoint is how that's going to function. In one of the upcoming releases, Pack 4 is public right now. Pack 5 is in the final stages of development. I don't have a date yet, but we're also going to be introducing a median subassembly that is going to be the back of road A and the back of road B, and it'll go ahead and it'll connect those for us. So we're just working out the last of the kinks on that one, so be looking forward for pack number 5 in the near future. And then we've also got some just generic links. I'm actually we'll come back to those min dots. And since this is going to tie to my right away, that's not really such a good tie-in, but we'll go ahead and use the link width and slope subassembly here. And the beauty of these, what I would be tempted to call generic subassemblies, the link width and slope, vertical deflection, slope to elevation, and slope to surface, or link to MarkPoint, is this is a shape. It's not just a link with 2 points on it. It's an actual shape. We can come in here we can modify the depth of this, and the default code for this is topsoil, which means that I can now quantify the amount of black dirt, the topsoil respread that I have to go through and execute on my project. Instead of just going through manually putting in some hatches or hatching it and then multiplying it by the depth, I don't have to worry about that anymore. And I can come in here again and I can change any of these shapes. Maybe I don't want topsoil, maybe I want to call that respread. Maybe I don't want point P2 for my outside top. Maybe I want, this is going to be BLVD out. Whatever I want it to be, I'm going to undo those changes because my code set's not set up to handle them. But if my code set were, and I was using all of these codes correctly, then there's really not a lot of limitation to what I can get my plan set to do for me automatically. So the link width, link slope, and the link to mark point, those all function similarly. You're just given a generic shape that you can go and customize the codes and the size and the slope for, and obviously with their different targeting parameters. And I'll go ahead and also add in the link slope to surface, which is going to represent our daylight. And we can do cut only or fill only, or both cut and fill. I will leave it at cut and fill with 3 to 1.5 foot of depth. Come back here and change that to 0.5 as well. And now we can go ahead and we can get this corridor retargeted. So I want to make sure my surface is set to the EG. And then my subassembly for this sidewalk boulevard from right-of-way, this is where I'm just going to go ahead and I'm going to target that offset alignment. This is a 70-foot total road, which means 35 on each side. So for that outside boulevard, I'm targeting the left right-of-way horizontally, and I'm targeting its existing surface profile from that as well. Actually, I don't have an existing surface profile. That's my design profile. So we'll get those targets updated. Someone can go ahead and, if you want, you can play the Jeopardy music in your head while you give me just a moment here. And then we'll go ahead and we'll take a look at this inside section editor. And what I want you to be paying attention to here in the upper part of my screen is how this slope between my sidewalk is changing as the existing ground moves up and down. All of the slopes in my corridor are staying the same as far as those set parameters. I've got a constant slope on my link width and slope on the outside. My lanes are staying the same. And even all of these parameters for my outside boulevard and my sidewalk are staying the same. But I've got link to mark point functionality built right into the subassembly for varying the slope between my top back of curb and my inside edge of my sidewalk. I didn't have to mess around with mark points and links to those mark points. So some other stuff that I want to show us here is the ability to start coming in here and customizing our codes. And the way that I'm going to do that is I'm going to just come out to my sidewalk boulevard right away here. I'm going to go find my code for my boulevard outside edge, and I'm going to add in right of way, ROW. And the next thing I'm going to go do is I'm going to make sure that my code set that lives under drawing settings, general, multi-purpose code set. Use my cross-section one here. We go through, I'm going to find a point code, and I'm going to see if I have something in here called right-of-way. And I do, which is great. If I didn't, I can come in and I can always go up to right-click on whatever point category I have and add a point. But with that, since this is a point, I want to make sure that I'm using my right-of-way offset label. which should be working just fine. I'll come into my assembly or my subassembly view, and I can see that that ROW code is hanging out in there. And now, when I go back into section editor, or if I'm using an actual cross section, which I'll go ahead and make one of those now because I'll need it anyway. Just a single one. At station 1000. Once I change this code set style in my corridor section to cross-section CTC, should be able to find, I've got a bunch of different stuff labeled here. I've got my center line with an elevation. I've got right and left offsets for my top back of curb, including their elevations, and a side indicator on those. And it looks like I didn't quite get the coding right for that right of way. Let's go back and fix it. A good old-fashioned rebuild there. There it is. So once my cross-section and that code set for my cross-section picked up that I had a point saying, hey, that's my right-of-way, then I've already got that building in here, and every single section that I have this corridor showing up in, or every single time any one of my subassemblies has that code right-of-way involved, it's going to generate that label. So what does this mean? This means we can do a whole bunch of stuff, even for our plans and for our cross sections as far as labeling is concerned. But we've got all kinds of other information that we can use for our code sets. So if I go to my corridor design code set style here, or I can even make a code set for plotting. And with this plotting one set up, now I've got links that I can use to generate a material area. So now everywhere I have a daylight, I'm going to have a hatch pattern for grass. Every time I have a pavement code for, in this case, that's going to be pave, I'm going to have this sand colored hatch, and it's all going to be the right size, color, and everything. And this is all talking back to my code set. Notice also that I've got pay items in my code set. So this is where we're going to take these codes and we're going to link them into our QTO for our drawing. What else can we do with points? Links, those are the cross section, building perpendicular away from our baseline. Our points, these are really the fundamental building block of our subassemblies. But this is where we can not only say, hey, do I want a label to generate right here, but we can also use these to create feature lines. So the flange code that is going into the edge of my curb, that's giving me a feature line. This is a feature line that I can extract out of my corridor. This is something I can use in plan production. And anytime my corridor updates, so too will the feature line of the corridor, or if I've set the extracted one to remain dynamic, my extracted feature lines out of my corridor. And lastly, shapes. These are what we're going to be using to create our volume that goes through the corridor. So this is anything that we're going to see inside a section view or what have we. And I'm going to go ahead and I'm going to add in two quick shapes here. I'm going to create a cut fill, and I'm going to create a a cut and a fill. And I'll use these in my material label. So for our cut, we'll go with red, and we'll do an ANSI 131. And I will create a fill. We'll go with 90 sorry, 100 and 131 again. We'll rotate that by 90. So we can now come through and we could create a material list for our cross sections. And this is pretty common. Not everybody uses the corridor itself to create those corridor or to create those volume tables and that volume information. Sometimes we just want to see that as a result of our sample lines, which when properly executed will be used to create, or they'll be falling on those corridor frequency lines. So with those up, I can go to Compute Materials, and I can go find some cut and fill. I want my EG to be my EG, and I need a datum surface here for my corridor. Not to worry. I'll just go grab that corridor surfaces. Or datum, corridor G. Bottom link overhang correction. And anyone that's been a student in my corridor classes should be ready to kick me. I forgot to add in my shrink wrap boundary. Come back in here, do that computation, get our cut and fill, set the EG to EG, set the datum to datum. Got my datum surface. Pardon me here, folks. Not exactly sure why that datum surface isn't showing up. Let's get to the next screen and see if we can't get that to shake out. I was having some issues. Things were working pretty well this morning, but my my data set was having a bit of an issue with us here right before things came in. And I really don't know why we can't get that datum surface to come in here. I do apologize for that, folks. If anyone has some suggestions for the button that I'm missing, please feel free to type that into your Zoom chat window for me. Otherwise, what I'm trying to say here is that when we have those shapes, they didn't necessarily have to be part of the code set style, but when we have those shapes of cut and fill put together, we can use our surfaces, our EG, and our datum surfaces, and we can go ahead and we can create nice cut, fill, line work, and hatching to show up here in our sections. When we're adding our material list to these sections, we can go ahead and add in any shape from any corridor that we're crossing or that's being sampled by the sample line. So I can put in my structures, some goofy things going on there. So I can go ahead and I can add in my paved one, I can add in my topsoil, and I can add in my base. And these are all going to be calculated for me. They're going to show up in my section. I can now include them in my material list. But without the codes, I couldn't do that. And if all you're using is the out-of-the-box subassemblies, then you're going to have a hard time getting the codes that you want, which means you're going to have a hard time getting the labels that you want for your variety of projects. You're going to have a hard time getting all of the different appearances that you want in section view, and you're not going to be able to quantify everything quite the way you may have been hoping to. So with that, I'm going to go ahead and take this webinar home. And so a couple of takeaways for how this was working. Oh, you know what? Actually, I want to show off real quick some of the other subassemblies that I said I'd come back to, those MnDOT, the Minnesota Department of Transportation subassemblies that are pretty great because not only does our regular curb have the opportunity to change its insertion point just like the normal one, not only do we have nice, easily defined codes, but we've also got a few different ways that we've pre-populated that as part of the Minnesota DOT. And with the MnDOT curb all by itself, we'll grab that curb and we can just go ahead and say, do we want a barrier, a V style, a Delta style, or a Sierra style curb? And all of those parameters are just going to pre-populate for us. We can go ahead and also switch this between a 12-inch flange or an 18-inch flange, and so on and so forth. So those are all per the Minnesota DOT specification. And the other really cool thing is for the version that we had included with the sidewalk, once we put the curb and the sidewalk together, we were able to define a new shape, a shape that you can't get unless you were to create this all as part of one subassembly. And that's the common area. So when I go through and I build this in the real world, yes, I have to excavate down for my base and then I have to come up. But I'm gonna put in my base, I'm gonna put in my sub base, and I'm gonna put in my curb and my topsoil on top and so on and so forth. But this is material that has to get put back in, and it's really easy to miss this, and it's kind of tough to define as part of your quantification for your project without having this shape in here. So I can come down and I can go find this shape code that says none, call that common, and now I saw that color update, so that tells me that I'm pretty sure it's part of my code set. And in fact, it was. So because I had that in my code set, now I can come through, I can quantify this. And that's a really fun thing that we were able to do with this combined subassembly that we can't find in any of the others. So if you can get your geometry roughly close, or if you can change this with a plan note, you could very easily use this curb setup in other regions too, or for projects where those tiny little parameters could be explained away or what have you, if you really wanted to have that that value in there. There's a variety of different ways you could go about doing that. And then lastly, for our customers who do have projects to work in metric, we have all 10 of the standard subassemblies available in metric sizes as well. At this point in time, the MnDOT is only available in imperial sizing options. So in conclusion, what did we learn today? We learned that most of the codes in our subassemblies are customizable. We learned that custom codes can unlock the dynamic creation of plan and cross-section objects. We know that some of the most common link to mark point workflows have been automated. In the current version, we've got the sidewalk to boulevard with the interior float. We've got a lane that can float. And in Pack 5, which is in the late stages of development, we'll also be including a median, which will float in between the two curbs of our separated roadways. Lastly, we know that we can still edit the CPP source files inside Subassembly Composer. So if you know that your survey team is always using the code BOC for the top back of curb, then you can go into CPP or you could go into the subassembly composer and you could just predefine this code for our point top outside of our curb. You can change that to TBC. It's going to show up in here, and nobody will be any the wiser. And your entire firm can work off the same standards. Plus, going into subassembly composer gives you access to the minority of the codes in the minority of subassemblies that aren't directly user editable. So with that, I want to thank everybody so much for your time today, and I will stick around for a few questions if anybody would like to. Thank you so much, everyone. And I am going to go ahead and unmute all participants. So if you're still here, just mind that for everybody else and go ahead and mute your end if you don't want to speak up, but wanted to give everyone a chance to ask any questions if they have any questions. All right, so not seeing any questions here, folks. I'm going to go ahead and end the meeting. One last time, thank you so much for tuning in, and we will catch you on the flip side. If you have any questions, Civil 3D related, corridors, or otherwise, feel free to drop me an email, kgroves@atgusa.com, and have a wonderful rest of your day.